This could well be the world's fastest accelerating road car. Ready? Wow! Wow! Oh my word! Welcome to Ariel's headquarters in deepest, darkest Somerset. This is where the scaffolding comes together. Obviously, this one's a Nomad, one of my all-time favourite cars. And here we've got an Atom. It's a real British success story. They build about 100 cars a year here. But what comes next? How does a low-volume sports car manufacturer make the leap into new technology? By doing things differently. Bodywork, for a start. This is the Hypercar, and don't think Ariel's overreaching itself with that name, although it will change. This develops 1,200 horsepower. 4 electric motors, one per wheel, mounted inboard and developing not only 1,180 horsepower, but over 1,300 pounds-foot of torque. The target is 0 to 60 in under 2 seconds, 100 in 4 flat. The biggest issue, besides your puny neck muscles and holding on tight enough, is getting that thrust to the tarmac. The rear tyres are vast 325s. For production, Michelin's stickiest Cut 2Rs will be used, wrapped around carbon wheels. Those are connected to the chassis by double wishbones. The suspension is a work of art, left proudly on display. Lurking in the depths is a 56 kilowatt-hour battery, half the size of the packs used by Lotus and Rimac. Yes, the battery isn't huge, but this has got a range extender. What you're looking at here is a jet engine that charges the battery. What we need is someone to talk us through it, and there's no one better than Ariel's founder and director, Simon Saunders. Okay, Simon, why have you got a jet turbine in the back of your new car?
Yeah, it's a big exhaust, isn't it? The turbine spins at 120,000 RPM. Mm-hmm. It's way more efficient than an internal combustion engine. We looked at rotary engines. We looked at different ways of doing it. It will eventually run on different kinds of fuel. So eventually it will run on hydrogen. At the moment, it runs on petrol. But it's a very efficient way of producing.
So relatively light and compact.
Yeah, I mean it's. Unfortunately, you can't see in there at the moment, but it's kind of this size.
There's an exhaust system that leads to it, so the turbine's actually buried further in, is it?
The turbine's buried in there on top of the motors. But again, like everything else on the car, it's as small as we could make it. And the reason for putting the range extender was so that you weren't reliant on a charging network. In normal or even fast driving, the range extender will keep the battery charged. So as long as there's some sort of fuel, for the range extender, you can just
carry on going. So it doesn't develop that much power, does it?
It's 35 kilowatts,
which is decent, actually, isn't it?
Which I mean, we have a simulation called driving like a twit on the road. Possibly not the twit word, but even in those situations, the cat gem will keep up with the charge of the battery.
So no matter how hard you drive
you'll never run out of charge on the battery. Right. When you move to the track, it's a slightly different story. It was important for us that the car had a track capability, but you couldn't do, for instance, you couldn't do a track day. The power requirements on track
just ramp up.
Just do this. So in those circumstances, it'll keep you going for a while, but not for a whole day. Let's say at those sort of speeds. Yeah. But in normal driving, you won't have to stop.
Is it noisy?
It makes a jet engine noise. You'll certainly impress people next door at the traffic lights.
You'll be the first people to get a jet engine into production.
Yeah.
Really exciting. Right, let's move on and talk about cooling. So obviously we've got some radiators down here with fans. Are you going to leave the fans on display for production?
We'd like them on display. We like things moving and being able to see things going up and down as on the Atoms and Nomads. So it'd be nice to be able to see them, yeah.
And you've got, well, these are not the only radiators you've got in the car. There's quite a lot of cooling going on.
On the car, we've got 8 different cooling systems.
Yeah.
The different parts of the drivetrain all want to be at a slightly different temperature. So it's why we've got so many cooling systems. It is one of the things on EVs. People tend to think they're very simple vehicles with a motor and a battery and off you go. They're incredibly complicated vehicles. And
Really?
also because we were insistent on the car having a track capability, that just makes the problems even more complicated because the cooling requirements, again, ramp up dramatically on track. But it's pushed the technology and it's pushed us, and we've got a better product out of it, essentially. So.
Good. Right, and then aero, talking about airflow through things, we've got a lot of aero, and it's very interesting. It's not like you haven't just shoved a wing on the back, have you?
No,
You've got a lot of downforce happening from down there.
There's Venturi, there's a lot of underbody work.
Yeah.
We've done hundreds and hundreds of CFD tests, computer fluid dynamics. Some of it is to do with obviously keeping the car on the road.
Because originally you'd looked at ground effects, hadn't you?
Yeah, we looked at sucking the car down onto the road. We did a project to do that. One of the problems with that is we had to be running very, very close to the road. So for road use, it was really difficult. We started looking at brushes and Venturis down the side. It got very
like
complicated.
70s F1.
But one of our requirements from you guys has always been it's got to get over a sleeping policeman and up a curb.
Yeah.
And those sort of things are important to us because otherwise, it brings you to a full stop.
Yeah.
The other side of it is getting enough air into the car and out of it again to make the 8 cooling systems work. So there is an enormous amount of aero in it. And in some of the small things on the car, the winglets on the front wings, which people puzzle about what can they do, they actually disturb the airflow over the mirrors. So the mirrors aren't creating drag. So as with a lot of aero, it's not necessarily the bit you're looking at, it's sometimes the bit some way down the car.
Right, well, talk about that. Let's go and have a look down the side of the car.
Okay, yep.
And then we can, see what we mean. So we've got here, so what you're saying is the front winglet is designed to break up the airflow.
This is actually breaking the air up. So this is not creating drag. So
and then the rear winglet is designed to bring the air back together?
The rear wing is just stabilising everything, stabilising the car. There's air going in and air coming underneath. There is a massive amount of aero work gone in here. I mean, this is the air intake for the range extender, which again is quite Goldilocks in character. It doesn't want too much air. It doesn't want it rammed in there. It just wants some air flowing over the top of it, which you can have when it wants it.
Right, braking, you've got a lovely big set of conventional brakes on there.
Yep.
Are you using regen braking as well?
We're experimenting with regen braking at the moment. It is a standalone braking system. We're also looking at having more driver involvement because a lot of EVs don't leave you very much to do. So part of what we're doing at the moment is experimenting with regen braking that you can actually switch on and off and adjust.
Because I assume if you're driving on a track, you want that consistency of brake pedal feel.
I think track driving, you turn it off, so you've got a standalone brake system.
Yeah, but I also, something you have definitely never done before, you've done a door.
We've done a door.
And I know that sounds like something, you've just done a door, but tell everybody how complicated this is.
I mean, it's one of those things that people you just slam your car door and off you go. It is probably the most complicated piece of engineering in a car is the door, and it's one reason why an Atom and a Nomad
never touched it before.
We were fairly apprehensive about doing a door, and we've spent hundreds of hours, lots of different hinges, experimenting with different locks, seals, and so on and so forth. And as with anything aerial, we just decided if we're going to do it, we're going to have to do it really, really well.
Yeah. But what I love is how it operates, because it really does operate beautifully. And it opens with a nice clunk and click, and it's a really attractive piece of design. Do you have to put sound insulation inside the carbon here?
There is. I mean, the interior, which we haven't finished yet, but it's not going to be a Rolls-Royce Bentley type interior with leather and buttons and things like that. We describe the interior, and possibly what you're talking about here, as plush Le Mans. So it's not a race car. It's one step away from that, but it's an aerial. Essentially, so you'll get what you need. We did a lot of work on looking at screens. We decided that touch screens weren't the way forward for a car like this because you're having to take your eye off the road. And so we've actually got relatively conventional buttons, as you see in the roof. We've got a way to go on finishing the interior, but it's certainly not going to be it's not going to be burr walnut and Connolly leather. So,
But what I noticed, I mean, you've got no step on the side sill here,
Yeah.
but the seats look like they're quite high in the chassis. Where does the battery sit underneath the seats?
So the battery is a few millimetres under the floor is the battery. So the battery is probably something, yay big. We pushed the battery engineers really, really hard.
To sort of try and lower that down?
Well, weight, space. So the battery actually sits underneath the whole floor, between the wheels and up into the tunnel. It was the logical place to put it. It also makes entry, once you get used to it, like most of our cars, getting in and out of this is actually fairly easy because it is a slightly higher car than a mid-engine sports car.
And I don't know if that's the reason, but it's given you a very interesting set of proportions because it doesn't look like any other supercar or hypercar. You look shorter, you look taller, you look a bit narrower.
A high-performance EV is a new car. There is no reason why it should look like a mid-engine car. There's no reason why it should look like a front-engine car because it doesn't have a mid-engine and it doesn't have a front engine. The look of the car was derived really from the engineering and the packaging. We wanted it, in essence, we wanted it to be an all-new car. That wasn't looking backwards but was looking forwards. The driving thing for us, as with our other vehicles, is lightweight. Our target weight for the car is 1,500 kilos, which to us sounds very heavy because these are a third of that. But for a high-performance EV, it's really light.
And that's with four-wheel drive, because you're going to do a two-wheel drive version as well, isn't it?
Yeah, the two-wheel drive version we want to get under 1,400. Which is obviously getting.
And will you do one without a range extender as well?
Yeah, the range extender is going to be an option on the car. The range driving conventionally, not necessarily like an aerial driver, is 150 miles. So a lot of people actually, that will be enough.
So this is your first prototype?
This is the first full-bodied prototype. We've got a lot of other prototypes. We're on generation 2. This is the first car with all the bodywork, the right battery, the right motors, all in one place at the same time.
And it's the one you're starting to do some driving with?
Yeah, we've started to do testing. We've got a lot more testing to do.
Well, I've only got one question though. I know you've got some testing to do. Can I have a go?
I think that would be a very good idea.
Excellent. Right then, Ariel's Hypercar. It's obviously in a fairly raw state of development. In fact, Ariel say they haven't done anything with the dynamics of it at all yet. And in terms of noise, you can tell. It's noisy in here.
Unfortunately, the jet turbine wasn't running, so as yet we've got no sense of what that sounds and feels like.
It's a wild thing to drive though. It feels fantastic in here. You sit quite high. You actually look down through the bonnet. There is no bonnet, but the view, the whole Batmobile effect of it is just amazing. I'm going to be quite careful with this one. But I've got some modes to play with. I've got Eco and Sport, and I've got Serious and Fun. And I select them by pressing a button up here, and then a button, whoa, hello. Instantly, as soon as you switch into Serious, it just starts, it's just bloody hell. It really wants to go. Now at the moment, they've got the throttle pedal set up quite long, and there's a bit of body roll in it and everything else, but hey, you know, it's behaving itself. The brakes work. The accelerator definitely works. The steering works. Steering's actually from a Ford Focus ST. Okay, it's a very raw prototype, but it does have the full whack of power. Right, get it in the right mode. So there's your mode select button, and we'll go for Serious, which manages the power, a bit more torque vectoring, more traction. It's a bit crude at the moment, but we'll go with it. In drive, handbrake off. That's it. Right, brakes, accelerator, go. That is intense, he says as it hiccups down the runway.
Yeah, if you're thinking that didn't look that fast, you'd be right. Battery power was running down, and filming the last run, the motors weren't getting the power they expected,
so started, to use a word from the combustion era, to miss fire. Just one more engineering niggle for Ariel to overcome. It's what a prototype is for.